All right, let's just pick up where we left off here. We had a polynomial of degree 7, and it had a positive leading coefficient, so it opened up to the right, down to the left like this. And we have our x-intercepts from each of the terms of the polynomial. What we were talking about is the fact that you can go straight through the intercept if the exponent on the factor is 1. You can bounce off the x-intercept if the exponent is 2. And if the exponent is 3, you need to jog. Or what I like to say is you approach the x-intercept like you're going to bounce off of it, but then you go through it. Okay, so we have to draw those ourselves. It seems to me we're going to bounce at 3, and we're going to jog at -4. Yeah, that's good. It's x plus 4 to the power of 3. That's our first one over here. So we have to be increasing and then approach the x-intercept. Notice how it kind of looks like it's going to be a parabola. But then we escape from the other side, also similar to a parabola. See, it almost looks like half a parabola there, and it looks like half a parabola there. It should remind you of the shape of an x to the 3 or cubic polynomial, right? Anyways, it goes straight through at 1, bounces at 3, straight through at 6. So we have to curve downward, straight through at 1, bounces at 3, and then straight through at 6. I missed, but that's okay. So we've got our x to the power of 3 here, our x squared here, our x, and our x. And each of those x-intercepts came from each individual term. Hey, we're done. Now I've strategically left the y-axis unlabeled here because we don't know how high this goes. We don't know how low that goes. We don't know how low that goes. We have other ways of figuring that out, but to be completely honest, it's mostly calculus, which is a different math course. If you really want to know what those points are, you can plug in like -1 or -2 or something in that area into the original function and get the height of it. Then you can plug in, I don't know, 2, 4.5. I'm just making numbers up. Just doing some test values to get extra points on the curve. I'm not so worried about it. Now, what I have noticed is that I've included the same graph twice, it looks like. Once on the previous page and once on this page. This is just the explanation. Double roots bounce off the x-axis, boing, and triple roots jog through the x-axis. It's called a point of inflection, but it approaches and then emerges the other side. What I am interested in is creating the equation for this graph. Now, again, I'm not so worried about this y-axis. If we could find a point that goes through, maybe it goes through that point there, 0, 10,000, then we could solve it fully. But for now, let's just worry about the x-intercepts. What have we got here? We've got a jog at -2. What that means is that we have an x plus 2 in our equation, and because it's a jog, or a point of inflection, I gotta start calling it a point of inflection, it's to the power of 3. The next x-intercept is here, at +1. That means we have a term x minus 1, and because it's a bounce, the exponent is 2. We have another x-intercept at 4. So, can you guess what goes here? X minus 4 to the power of 1 because it goes straight through. And we have another point of inflection at +7, which means we have x minus 7 to the power of 3. So we've already accounted for all of these x-intercepts. To create the full equation, we need to put a leading coefficient in. I'm going to call it a. And then you've got to plug a point in for x and y. Let's say, and by the way, that point can't be any of the x-intercepts. Let's say this is a point here, 0, 10,000, which means my y is 10,000, and all of my x's are 0. 0 plus 2 to the 3, 0 minus 1 squared, 0 minus 4, 0 minus 7 cubed. We can do all that math. 10,000 equals, yeah, I don't feel like doing that myself. So 2 to the power of 3 times negative 1 squared times negative 4 times negative 7, but cubed. That gives me, oops, maybe you want to see that, 10,976, positive. And so my A is 10,000 over 10,976. I don't know what that is as a decimal. 0.91. A equals 0.911. Shorty call 911. Shorty fire burning on the dance floor. Whoa, whoa. Anyways, I'm putting it in. I'm plugging in that number for the A and regurgitating the rest of the function out. But you had to plug in an x comma y to figure out what the A was. You've done this before. You had to solve for A in a parabola once, maybe twice. Shouldn't be a surprise. Gotta do it here too. Curve sketching polynomials. It's pretty fun once you realize that it goes straight through for a 1, bounces for a squared, does this little point of inflection thing for a 3, and you can even use that information to create your own equations. Quelque partie, mesdames et messieurs. Best of luck.